Ask about quizzes or anything else? So next week is a short week. We don't have class on Monday or next Thursday, so we only have class on Tuesday and Wednesday. And then, all right. So let's look at some percentage stuff. So the examples I gave you, the first one was a question about tax. So the idea was that you had this tablet that cost $349. Then I gave you the tax rate. So the cost was $349, yeah, and then the tax rate was 6.5%. And then I asked you to figure out the tax and the final cost. So if you're going to calculate tax, how do you calculate a percentage of a number? It's just what? It's the percentage times the number, but what do we always have to do with our percentages when we want to work with them? Yeah, we always need to work with our percentages in decimal form. So we need to move that decimal over two places or divide it by 100 if you're using a calculator to do it, but it'll come out to 0.065. So the tax will just be the percentage times the cost, and then that'll come out to be something. I don't know. What does that come out to be? Anybody do that? 2269? Is that okay? So that's 2269. Perfect. So that would be your tax. If you wanted to find your final cost, what would you have to do? Yeah, you just take the original price, $349, and you'd add on the tax, and that would come out to be what? $371.69. That'd be your final price. Yeah? Yesterday I showed you that you can get the after-tax price directly. Like if you're at the store and you're trying to figure out, what's something going to cost after tax. If you just multiply it by 1 point, whatever the percentage is. So you could try it out on your own if you wanted to. But if you took 1.065 and you multiply it by 349, it'll actually get you the after-tax price, because that's 100% of the price plus the 6.5% tax. And you can use that trick anytime you're trying to tack on a percentage to a value. All right? So I'm just going to go through these. Let me know if you have any questions as we go. All right? So then the next one was like hotel room. You got $179 per night. You stay 3 nights. Hospitality taxes are usually higher on hotels than they are like on regular purchases. So it's 11.8%. So first, if you're staying 3 nights, what do you need to do to get your cost? Right? We need to multiply that by 3. That's going to come out to be 500 and what? 537. Okay. So that would be your before tax cost. Then if you wanted to calculate the tax separately, well, if the tax rate is 11.8%, then what do we need to do? We need to turn that percentage into a decimal by moving that decimal place over 2 place values, and then you can multiply by 537, and then that'll give you some number. What does that come out to be? 6337. I was about to say, that's some pretty awesome tax. 6337. If you calculate that, other people get that if you put it in your calculator. Perfect. Then if you want to get your total, you just combine. So then you just take your 537 plus the tax, 6337, and then that's going to come out to be what, 100? Is that 600 even? 637 cents. So, all right. Again, you could have gotten this number directly from the cost of the hotel if you were trying to get the after-tax price and you didn't care about the tax itself, you just cared about the final bill. You just take 1.118 times 537. That puts the cost and the tax all together and would spit out that final number. So, all right. So far, so good? So most people, not too bad. If I give you a percentage and a price, You can most people are okay calculating tax or discounts and finding final prices. If I give you dollar values though and not the percentage, you just have to be a little bit careful. Though you can kind of cheat a little bit on problems like the next one. So the idea was that there was a dress, and the dress price was $129, and then the tax charged on that was $9.03. Okay, and then the question was, okay, well, what's the tax rate, right? So as a percentage. So how would you do this? We did problems like this yesterday, so how would you solve this one? Right, the tax percent. When you're calculating a percentage, some people, I was mentioning, they'll think of it as like calculating the part over the whole. I mean, we know the thing is that if you're calculating a percentage rate, like off of tax or commission I mentioned, it's pretty much a safe bet. You can take the smaller number and divide by the bigger number. That's almost always going to be the case. And so it would be 903 divided by 129. And the reason why is what we're really trying to solve is we're saying that 903 is what percent of 129. That's really the question we're trying to answer. And when you frame it as an is-of equation, 903 is what percent of 129. The equation shows you that the right thing to do is to take 903, and then you would divide that 129 on both sides. But if you recognize the problem, then it's pretty clear that you just need to take the small value, divide by the big value. Okay. So if you do that, what do you get? 903 divided by 129. What does that give you? 0.07. Yeah, and you just have to be careful. Remember, just like we turn our percentages into decimals to work with them, when we work out problems like this, that's the answer, but it's going to come in decimal form. So if we want to put it back in a percentage form, we need to correct. And so that would be a 7% tax rate. So, all right. Question about that? So if I give you the percentage and the price, you turn the percentage into a decimal and use it that way. If I give you the price and the tax, then you just do the division and then you correct and bring it out of decimal form back into percentages. All right, the next one is actually pretty similar. So the sale of an RV, so the sale was $19,500. And on that sale, the person who made the sale gets a commission. Let's say they got $487.50. And so my question is, well, what was their commission rate? And what I mean by that is percentage. But this one's a lot like the other one because it was just a percentage calculated on that initial value. So if you recognize that, then you can just sort of shortcut it and know that what we're going to do is 487.50 divided by 19.5. And if you do that, what does it come up with? 0.025. Okay, but you also have to recognize that what is that? That's the decimal form. So what's the answer as a percentage? You do the correction. 2 decimal places. And so it looks like it's a 2.5% commission rate. All right. Again, you could frame it as an is-of equation because it's like the last one. What we're really asking is 487.50 is what percent of 19.5, and then if you set up the equation, it tells you that the right thing to do is to divide by 19.5. So, all right. Questions on either of those? But again, the safe bet is typically we take the small number divided by the big number. You're usually going to be in good shape. The next one is a little bit different because I don't give you the discount price or the increase or whatever. I'm giving you the 2 different prices before and after a discount. And so this is what we call like a percent change problem. So So when you're dealing with a percent change problem, the idea is that there was an initial price for a sofa. So the initial price was $1,500, and then after a discount, she actually paid $1,275, right? So she received a discount. My question is, what I want to know, well, it was a two-part question, but my ultimate question is, what was the percent discount? Like, how much percentage discount did she receive? So I broke it down into two parts because first, before you can calculate a percentage, what do you need to do? Yeah, you got to find out the dollar amount on the discount, right? So the dollar discount is how much? How much does she save? Yeah, so you do, whatever. You just do the subtraction. So that's the dollar discount. So she got $225 off. Now, if you want to turn it into a percent discount, then what should you do? That $225 should be what? Divided by? Yeah, it should be divided by 1,500. Now, why should it be divided by 1,500 and not 1,275? Yeah, so you have to remember that this discount, it was taken from the original price, not from the final price. Like, that was the initial sticker price, and this was taken from that. So when we calculate the percentage, it should be a percentage of the original value. And so this is the calculation. What does that come out to be? 0.15? 15%. Okay. In general, if you're trying to calculate a percent change, what you do is you take the original value. Wait, did I do that backwards? No, it should be the new value. I think in general, you would take the new value minus the original value, and then you always divide by the original value. Okay. So it's always the difference divided by the original. And that would be percent change. And this will work for percent increases and percent decreases. All right. Questions about that one? Just remember to always divide by the original amount. All right. The very last one, this one is a markup. We didn't actually do a markup example, but a percent markup means you just take a percentage of the item and then you just tack it on, right? And so this one says that the idea is that he takes bikes, sells them after he fixes them up, and he uses 125% markup. All right. So the question is, if he buys the bike for $75, and then after he fixes up, he sells it with 125% markup, then the question is, well, how much would he charge for the bike? Okay. So what do we need to do here first? Yeah, first we got to figure out, well, what is 125% of 75? Because that's how much he's going to mark up. And so, but anytime we're working with percentages, we need to make sure we do decimals, right? So we need to convert that. So we would do 1.25 times 75. That's going to get us 125% of 75. And if you do that, what does it come out to be? 93.75? Yeah. So in this case, he's doing more than 100% markup, and so he's actually more than doubling the price when he marks it up 125%, which is possible. It's feasible, right? So you can have more than 100%. Now, so then the final price then is going to be what he paid plus the markup, and so that would be 168.75. So I'll do the answer to that one. All right. Sound good? Questions about that? No? Everybody feel okay with those examples? Okay. So then, along with some of these taxes and commission problems, those are probably the way that you'll encounter interest most often in your own lives. The other way that you will often encounter percentages in a day-to-day is when you're dealing with interest. Okay? So an interest can occur two ways. So typically, you either are earning interest on investments or you're paying interest on loans. Right? So what is interest on a loan, for example? What's the idea? I'm sure a lot of us have paid interest on things. Car loans, credit cards, something, right? Okay, so if I want, yeah, right. So it accumulates, and it's like if I want to go buy a car, but I don't have enough cash to buy the car, what do? I take out a loan, right? And a bank gives me money to buy my car, but then what do? They turn around and they charge me interest. Why are they charging me interest? Because they're greedy. In some ways, maybe that could be the reason. But for practical reasons, why are they charging me interest?
So they get their money back plus a little bit more.
So yeah, for one, because they're giving me money, and so they don't have that money to invest themselves. So they're trying to make back some of the money they could have made if they didn't give it to me. But the other part is what? Why else do they charge interest? Profit's part of it, so that's like the greedy part, right? So part of it is they need to make money. Part of it is they could be making money with the money if they weren't giving it to you. And the other part is what? Why do they charge me interest on my loan?
To make you pay it back.
Yeah, because I might not pay my loan back, right? I could default on my loan. Like I take out a mortgage for my house, right? And that, a bank's putting up like $250,000, $300,000, whatever, on a mortgage or something, right? Well, what happens if I just decide I don't want to pay for my house anymore? I don't want to pay for my house anymore. I'm just going to move, right? Well, then what's the problem? So it's not. There is definitely some greed and predatory lending, that's for sure. But part of it is just practical, right? They have to take into account the risk that you might not actually pay them back someday. And so, anyways, the point is that if you take out a loan, you're typically going to be charged interest, and interest comes in a percentage. And but on the flip side, if you invest money, you typically get paid interest, because it's like the flip side. When you invest money, you're actually loaning your money to other people to use. So, anyways, there's lots of ways that interest can be calculated, but we're just going to look, for the sake of this class, at what's called simple interest. Okay, so. Simple interest is it's different than what you would have like on an investment or a credit card or a car loan. That would be compound interest, which I'll mention in a second. But in simple interest, there's some terminology. So capital I is usually the variable used to describe the interest, right? That's like the extra money on top of the loan or on top of your investment, right? So when you pay back your loan on the car, you pay more for the car than you actually, you end up paying the cost of the car plus interest. Then usually a capital P is used to describe what's called the principal, right? And then that's like the initial amount of the investment or the loan. Okay. Then there's typically associated with it, like we call it little r, that's the rate, right? And that's the percent that they're going to charge in interest. And then there's also a factor of time. There's usually, like, for example, a car loan or a mortgage, there's like a specific amount of time that you're agreeing to pay the loan back in. So T is usually used to represent time, and that's in years. All right. So, if with all these variables in play, then to calculate the simple interest, that you're going to charge someone for a loan, if it were structured as simple interest, then the formula says that you can calculate interest by taking the principal times the rate times the time. So that's the formula for simple interest. We're not going to get into any more complicated types of interest in this class, though you probably will if you took your next class. So you can calculate the interest that you owe on a simple interest loan by doing principal times rate times time. And that'll tell you how much you're going to owe in extra costs on top of the loan. Now, if you went to the bank, they're probably not going to offer you a simple interest loan. But let's say, for example, that you decide to borrow money from, let's say that you borrow money from, I don't know, we'll just say, like, not everybody can borrow money from their parents, but let's say somebody does borrow money from their parents, right? So let's say you borrow money from a parent to pay for a $3,000 car. Okay, and what you do is you agree to pay like 3% simple interest over 3 years, or let's say, yes, sure, 3 years to pay it back. Okay, so you say, hey, I need this car. I'd like to borrow $3,000 so I can pay for the car. And the person says, okay, sure, I'll give you $3,000, but I'd like you to pay me 3% interest over 3 years. So then by the end of 3 years, you pay off the loan and you pay off the interest that you owe them. And so we can calculate the interest, and we can calculate the final cost as well of the car. Okay, so to calculate the interest, if you use simple interest, right, then we're going to use this formula. Okay, now we get to use some of these variables. So, like for example, P is the principal, it's the initial amount. What would that be in this case? It would be what? Yeah, the principal is the $3,000 that you initially get loaned out. What's the rate?
3%.
Yeah, that's the percentage that you agreed on. And then what is 3 years? 3 years is your time. Now remember though, we're always going to use percentages in their decimal form. So we would say, okay, so that's $3,000 at 3% interest for, there's a lot of threes here, 3 years. Okay. So that's, I'm just making it worse. So $3,000 at 3% interest for 3 years. If you calculate that, what does it come out to be? I think it comes out to be, looks like it's going to come out to be 270. Yeah. So that means, so basically that means that you're agreeing to pay $270 on top of the $3,000 that you borrowed. So then when you come back to pay them off, then what happens? You know, or when you pay, if you're deciding how much your payments should be, like if you're going to do a fixed payment like a lot of car loans are, then you would say, okay, well then what's going to have to happen is I'm going to pay off $3,270, and then you can split that into equal payments or whatever. But that's going to be your total cost. Yeah? That makes sense? It's basically like calculating tax. It's just that you have the extra time thing with, if you do like a certain loan, you should multiply by the time. Because this is 3% of 3,000. That would be like a tax calculation, but you're doing it multiple times, so you multiply it. Okay. Yeah? And then, you know, assuming you pay it off, everybody's happy, right? You're happy because you got your car. They're happy because they made a little money. And everybody wins. Ish, I guess. Okay? All right, so then similarly, this works like for investments. So let's say, for example, let's say that you decide to invest, I don't know, like say $500 in a, what is the word I'm looking for, mutual fund. So if you end up if you ever end up getting a job that has like a retirement plan, typically most people invest money in what are called mutual funds, which are just like big pools of money that some investment bank, they manage. Okay, so it's like you just put $500 into the pool, and then anytime that mutual fund makes money, you get paid the same percentage that they make. So it's lots of people's money pooled together so that they can invest at into big funds and stuff. So anyways, so let's say you invest $500 in a mutual fund, and let's say that it returns, say, 8% simple interest over, say, 5 years or something. So then the question is, what's the value after 5 years? So how much money would you have after 5 years? Okay. So what's my P here? 500 is my principal. What's my rate? 8%. What's my time? 5 years. Okay. So we can say, so then the interest equals P times R times T. So we take 500 times 8% times 5 years, and what would we get? What is it? 200? $200. That would be my interest, right? So then what would be my new value of my investment? We started with 500, we earned $200 in interest, and so now we would have $700. Okay. So this is the interest. And now then $700 would be your new value. Okay. Which is not bad. I mean, $200 over 5 years is not a lot of money, but it's free money. You didn't have to do anything for it. Right? And anytime somebody wants to give me money for not working, I'm always going to take that money. Right? The other thing too is, this is a scenario where it's simple interest, but typically that's not actually how it works, right? Because imagine at the end of that 5 years, you decide that you don't actually need that $700 and you want to keep it invested. Well, what if you went another 5 years? So what if you went another 5 at 8%? What happens? Because now, how much money do you have? See, what happens is you get to take that $700 and you still get your interest, but now you're earning interest on $700 instead of $500, right? So now what would be, if you went another 5 years with your $700, like you reinvested it, how much interest would you earn then? What's that come out to be? 280. Right? So now, in the first 5 years, you earn 200, but then now you're earning interest on interest. So you're making money on the money that you made money with. Right? So then, what's your new balance at that point? It's $980, right? And then, what happens if you go another 5? Right? If you go another 5 at 8%, well then you have $980 to invest, and even if it's the same deal, well then how much interest do you earn if you do it again? So what's 980 times 0.08? What is it? 392. Right? So that time you earn $392, and then that gets tacked on to how much money you have. So now how much money do you have? You have $1,372. Right? And so you see what happens is this is where you get what's called compounding interest, because the money just keeps compounding. And then when you reinvest the money, not only are you making money on like the initial amount, but then you're making money on all the money you made. So you're making money on money. And that's the idea behind long-term investments. And then you can see not only is your balance going up, but the interest you earn is also going up. In the first 5 years, you only made $200, and in that third 5 years, you made almost twice that. And if you keep going up, like if you take your $1,372 and you earn another 8% for 5 years, now how much did you earn? We'll just do it like one more time, but you get the point. What would that be? Is it 548? Yeah. And so now how much money do you have? 1920? Is that what that adds up to? 1372 plus 548? Did I get that? 1920. Right? So by reinvesting the money, now we've gone through 4 cycles. And so in the first cycle, you don't necessarily realize a lot of profit, but then every cycle after that, your profit goes up and up and up. And so your initial $500 after, what is that, 20 years is now worth $1,920. So you've like almost quadrupled your money and you didn't even have to do anything. You just left it sit in an investment, right? And then the longer it sits there, the longer it's going to go. And this is actually conservative because this is simple interest. In reality, you have compound interest because the stock markets you're basically getting like continuous interest because they're trading constantly. So credit cards are usually evaluated like on monthly interest. Mortgages are as well. But investments that you invest, you get interest way more frequently than that because people are trading, infinitely many times per day. But anyways, so make sense? All right. So interest can work for you, but it also works against you because in this case, this would also be working against you, like say if you had a credit card balance or something that you don't pay off. If you just let it compound over time, then you're going to be in trouble, right? And so it's like it's a good idea to at least pay off your interest on a credit card because if you just let it roll over, not only are they going to keep charging you, but you get charged more and more and more every single time because they're charging you interest on the interest. So, all right. Any questions on those? All right. I think rather than going on to the next thing, I'm just going to stop there, and we'll just call it a day early today. I do have a couple. There's 2 things on this, and it actually goes across sections. And so I'll hand it out to you, and you can try the simple interest calculations. Next week, it kind of makes sense to separate these. We're going to look at proportions rather than percentages. So I think I'm just going to save that for next week. So you can, if you know how to do the last portion of this practice worksheet, you can go ahead and give those a try. But otherwise, just focus on the top 3 problems here, which are percentage problems. And then we're going to talk about proportions next week. I don't really want to get into that today. I will see you next week. Have a nice long week. Yeah, I'm not going to call it that. Because we'll come back and do the proportion stuff next week.